cycle. And you see, the more you eat, the less NAD you have. Nicotine adenylonucleotide. And the less NAD you have, the less your genes are not silenced, because this is involved in the so-called gene silencers. We need the silencers of the gene for the repair, for being quiet, for sleep, like you want to sleep, you know. So the more you eat at the end of the more you have NADH, and you see they're too easy to distinguish, nearly the same age. You see the right side, the guy who eats at libitum, the other who was caloric restricted. And the caloric restriction, the secret of caloric restriction at the end is the NAD-NADH ratio is higher. And so far, this protein, which is called sirtuin, SIR1, SIR2, SIR3 in the mitochondria, this sirtuins can be activated, you know, by caloric restriction. And in the moment it's activated, the proteins, the histone code of the DNA is deacetylated and can be slept. Same as happened with the methylation, another process. And here again you see this, you know, you have improved glucose and fat metabolism if you increase NAD and decrease NADH, which at least is, you can say, decrease ATP production. So what can we do? In a practical thing, I always tell the people, you make 1 to 3 days a week. You don't eat after 4 o'clock, 16 p.m. Why? Because then you have a long time of fasting. And you know, if it's not the day where you have a meeting with your friends and so on, yes, it would be not social. I would say she is antisocial, you know. But if you do that, last day, then you can follow the 3 days, skipping the dinner at the end, or you eat the dinner at 4, you know. But I don't think you need. At the end of my experience is, if you have the lunch about 2 or 3, you don't need eating after 4. You're not hungry. And you drink, but you have to drink a lot of water, or green tea, or tea, or whatever you like to drink. You know? So you see here, again, the NAD, which is inducing the sirtuins, inducing deacetylation and methylation. And at the end, this whole thing is called epigenetics, and epigenetic is one thing which is happening every second, every minute, every second is better said, and happen especially in the younger age. So that's why I think anti-aging, you know, it's not for people who are 75. Anti-aging is for women who are pregnant, and it's anti-aging for their babies. Because what happens when the woman smokes, or when the woman has a food with high sugar, what happens for the kid is diabetes and lung cancer, if the kid has the genes for this. You know, if there are genes which, well, let's say glutathione S transferase M1 and T1 nucleotide, then you probably have the situation here that when the woman smokes, this kid will have later lung cancer, because it starts smoking as well. The mother, you know, activates a lot of genes like cigarette cravings and so on, and this kid starts smoking as well. So that's what we see. The youngest patients are the patients in the womb. We see, we treat the mother, we explain the mother, what to do, and then they come the kids when they are born. They are not so much in danger anymore because the mother had already known. But there's no age where you cannot start, you know. So there are mimics of the sirtuins which are worked. This one star molecule is resveratrol in the red wine, and which is a nice way to keep your life happy, and drinking 1 glass of red wine, and or 2 glasses as a man, and you know, prevent yourself. If you are not allowed to drink alcohol, which is fine as well when there are resveratrol capsule supplements. Sirtuins and metformin is another one. Metformin reduces the energy as well, improves the energy burning in the muscle, improves insulin resistance and reduces the gluconeogenesis in the liver. Antidepressant as well. Why? That's very important because they reduce the inflammation in the brain and they increase the neurotransmitters in the brain. And neurotransmitters play a big role. If you ask the centenarians why they are so old, you ask them why, they don't say, because I have NAD low and high and so on. They say, because I'm always happy, I'm always laughing. And that's what the neurotransmitter. The brain seems to be an important regulator of our age. And brain aging is really not a good way. And the progressive damage to brain cells with oxidative stress or Alzheimer's disease, Parkinson's disease is not good. Hormone reduction. I told you hormone growth hormone, we already showed this, plays a big role. Hormone reduce over lifespan, and we know when we give hormones we can not only prevent diseases like osteoporosis, a nightmare for women in the postmenopause, we can even get reduced cardiovascular disease depending on the genetic profile of the woman. Men lose their hormones as well, and testosterone has been shown, low testosterone has been shown a very important point in the risk for aging. Sex hormone, if you see the Canadian women and men with sex hormone, you see that the Canadian have better hormones even in older age than the American. And low serum testosterone levels are involved in higher mortality for men. And that's why it's important. And that's what I told you at the beginning. Erectile dysfunction is a point, the portal to the doctor's door. You can open the door with erectile dysfunction, decrease of libido, and you treat all the other things of the man, all the other risks. All right, we have growth hormone. Growth hormone reduced as well during the age, and is as well very much involved in cardiovascular risk factors, obesity, increased fat mass, decreased lean body mass. DHEA is a hormone which you have heard very many times, and it's very controversial because we don't even know if it's a precursor hormone for androgens and estrogens. It is on one hand. In female it's more androgenic, in men it's more estrogenic, but it has directly effects, and this is very good evidence for antidepressive, increasing the neurotransmitters and immune stimulation, where DHA is a TH1 stimulating hormone, which directly goes to TH1. That's why we use it for the treatment of lupus erythematosus as well. And it's not good to use for other diseases which are TH1 diseases. So, yes, cortisol, the cortisol levels are going down, and we know that siblings which have lower salivary cortisol levels have a shorter lifespan. So there are really neuroendocrine situations in life, and they are correlated to the immune system. And here you see melatonin, for example. Melatonin, the pineal gland situation, it works directly on the TH1 as well, increases TH1 and increases killer cells and so on. It's pro-defense hormone like DHA as well. You see the cortisol reduces, cortisol increases in age, DHA goes down, TH1 goes to TH2 more, so the balance is gone. We have more allergies when we're getting older. It's, for women, it's like a pregnancy state. So immune aging is a very important point, and one thing is important, that the naive cells which are produced every time when you have an infection are low, while the effect memory clones are going up. The thymus shrinks during the time. That's one of the reasons, and at the end of the day, we know that we have as well, growth hormone is very good for the immune reduction. It's extremely good, but melatonin as well. And there are really risk factors, phenotypes, which are risk factors for earlier death. Longevity genetics, if we go to the genetics, we know one gene is very important in human being, that in the middle of everything there, the FOXO3 gene, the FOXO transcription factor gene is involved in longevity, and this is all to do with oxidative stress and reduction of oxidative stress, like it has been found in the worms and mice and primates. The FOXO3 genotype has been found in, this is a German study, the German population with healthy aging. So it's a stem cell treatment, the fountain of youth as well. We heard today a lot about stem cells, so I don't go too deep into it anymore. We have the hematopoietic stem cell and mesenchymal stem cell, the two from the bone marrow. Mesenchymal stem cells we find as well in the skin, we find in the fat tissue. The main thing in adults, in our adult situation is that we have, when the cell is apoptotic, we have a replacement by a niche where the cells are living. They're converting into progenitor cells, and some of these, half of this is progenitor cells, the other half is dividing to fill up the missing cell pool then. So we have a symmetric cell division and asymmetric cell division. One is going to replace and the other has to be replaced the cell pool again. So the cell pool stays always in the same amount of cells. As you can see here, progenitor division is number 3. Progenitor cells, while in number 2 you see the cells, which is one progenitor cells goes into the maturation and the other one is still there for keeping up the cell pool. And when we use them for sure for what is extremely good evidence in many case studies, unfortunately not so much in big studies, is Parkinson's disease, spinal cord injury, heart failure. Diabetes is not primarily, diabetes type 1 is a problem because this is not an autoimmune disease and you cannot actually overcome the autoimmune problem right now. Hepatocytes, yes, osteoporosis, bone fracture, the joints are good. As far as chondrocytes, in the biotechnology for doing cartilage, I have good relation to a company who works with this in Regensburg in Germany. They told me that they have problem to make the real cell-enriched cartilage. They can very good do the fibrous capsule, but the hyaluronic acid, the cell-enriched, is not easy to do. And to see what we can do with mesenchymal stem cell, the mesenchymal go to the adipose cells and going to the cartilage and muscles mostly. So what many companies are doing, they're doing the harvesting, but the mini lipo and cells from the fat, mesenchymal cells are all over in the skin and the fat in the blood. You can do apheresis, you can do bone marrow aspiration, you know, when you deal with the fat, the floating, but you can do the same by bone marrow aspiration or whatever, and you can use them for treatment then. You see this was in a journal which I once was the editor of. This one is done by brain, and you see after myocardial infarction, you have always a muscle, the part of the muscle which is very weak, and it's not taking part of the pump function anymore. And the ejection fraction is very low by the heart because of this. If you inject the mesenchymal cells to this part, the muscle itself is going to be, again, part of the injection and the increases the ejection fraction. One group of cells I want not to stop to, it's very important to mention this, that the ABCB5 cells. ABCB5 cells are very interesting cells. They are cells found by a group in Heidelberg and Harvard, and they are treated, and they are mesenchymal cells which are pluripotent. So that's not usual. Mesenchymal cells are multipotent but not pluripotent. So they are pluripotent, they have this special surface marker, ABCB5, and they are harvested by skin biopsy from here. It's very easy to do as well, and then they are cultivated. And unfortunately, as nearly in all the things, there's a progressive decrease cells as well, and the activity of the cells is not good as well in the aging population, so it's good when you do it as early as possible. And bank this. So we can do a lot of things. We can recognize the potential for healthy, successful aging, reduce excess disability, recognize replacement, regenerative treatments, and all this together. We need more research for sure. You know, we need better understanding common risk factors for disease. We need new approaches, intervention, muscle strength, muscle mass, immune function, cognitive research. Thank you very much. Any questions? Please.
Thank you for your presentation. You indeed explained very deeply for everything which we wonder about. But I just have two questions to learn about maybe more information. What do you think about for inflammation, omega-3? Then the second, maybe we talk about very complex situations and buildings, but there's a very simple, maybe not treatment, it's a need of cell. What do you think about water, treated water maybe?
Okay, thank you very much for these good questions. Number one is clear, omega-3 is one of the best possibilities to moderate inflammation, not to suppress inflammation. It's a big difference. If you suppress inflammation, you run the risk, big risk, because inflammation is necessary as well as a signaling process in the body. If you take suppress, I mean, for example, if you give someone Cerebrex or Vioxx or whatever, which Vioxx you remember very well, which suppressed extremely and the people died, because you need the inflammation for the stem cells to recognize that there's a problem and they will go there. So they don't know where to go. And that's number one. Number two is omega-3 works very well in this pathway and the cascade of the arachidonic acid pathway and stop this. The cyclooxygenase, but as well the NF-kappa B transcription factor activity modulates it more, not stops it, modulates it better. That's why it's good, you know, it's modulating, it's keeping the right balance, you know, it's very good. Regarding the water, I am not very aware of these different waters. I heard a lot of this, you know, treated water, and you know, which they have some stones in it, energy. It's actually interesting to go to this. This goes to the point where I told you when we spoke about the physics. You know, the physics is not a part of biology right now. Not really. It's a big part in mathematics and nuclear bombing and whatever, but we don't talk about this too much. But it should be, because physics is important. This is, you change the structure, the water structure, you change the frequency of, for example, of the H2O molecules, and the bridges are longer or whatever. So that's very interesting to see. But nevertheless, drinking is a very important point. Water drinking is a very important point. The cell need water, and we know it when we are dry. You know?
Especially in the free radical reduction.
Yeah.
This is very important.
Yeah, very extremely good addition from you. That you know, the taking up free radicals is a very short moment. I don't know how many microseconds it is, but
it's a blink.
Yeah, it's a blink. You know, it's very interesting. Thank you.
Thank you.
Thank you very much. Any questions? Dr. Nasri? Thank you.
We really appreciate and thank Dr. Klenze for this unique talk. And now first day is today we finished the program. And, yarın tekrar sabah saat 9'da bu sefer klinik ağırlıklı bir session yapacağız. Cerrahlarımız ve doktor